The James Webb Telescope continues to keep astronomers on the edge of their seats in 2025. Webb's latest series of images doesn't just show us snapshots of the universe, it shows us space in motion. This allows us to follow firsthand exactly how the breathtaking light echoes shift over time and how the gigantic dust rings gradually grow larger and larger. And yet, the Webb telescope has not only provided us with extremely impressive images but also with a direct insight into the overwhelming processes of the cosmos, some of which even seemed completely invisible before. At first glance, you might think that the following images show us one and the same thing, but if we compare the two pictures directly, we can see that the structures of the cosmos truly never take a break. In detail, we see the double star system WR-140, which lies about 5,000 light-years from Earth and contains a Wolf-Rayet star, a very special stellar outgrowth. In fact, Wolf-Rayet or WR stars for short are not only extremely rare but are also nothing more than the exposed cores of massive stars that cannot be assigned to any of the usual spectral classes but are classified in their own type. In the case of WR-140, Webb's infrared view has revealed 17 separate carbonators dust shells that are created when the stellar winds of the two objects collide every 8 years. Furthermore, the observations revealed that these dust shells move at an impressive speed of almost 1% of the speed of light. That's about 2,600 kilometers per second. In the same breath, the structures not only provided the researchers with valuable insights into the dynamics of such double star systems but also with the realization that dust formation does not occur evenly. In fact, we also find clusters here that form delicate clouds the size of our solar system. And although the corresponding structures are fragile in and of themselves, they play a crucial role in the life cycle of stars and planets. Specifically, carbon is a fundamental element for the formation of rocky planets and the chemistry of life, and such carbon-rich dust shells as we see here in the images can travel gigantic distances and thus contribute to the birth of new stars and planets. Has the mystery of the universe breakers finally been solved? But the James Webb Telescope is not only able to detect the dusty lifeblood of stars and planets, it has also spotted some extremely confusing objects that seem to overturn everything we thought we knew about the development of the young cosmos in one fell swoop. As is well known, the $10 billion equipment has also already discovered a whole series of early galaxies that shouldn't actually exist in this form, and for a very simple reason. Although the early galaxies only existed a few 100 million years after the Big Bang, they already appear to be as massive as our Milky Way is today, and that shouldn't be the case, strictly speaking. After all, our established models say that there simply wasn't enough normal matter present at that time to form such large galaxies. In view of this, the experts initially suspected that they must have made a fundamental mistake in their examination of these mysterious little red dots. But subsequent checks showed that this was simply not the case. And so it came about that the so-called universe breakers plunged astronomy into one of the greatest crises in its history, and that many a space explorer began to sing the swan song of our standard model of cosmology. But now, and this is the surprising news, the tide seems to have suddenly turned, and it appears that the ominous structures will not plunge our understanding of cosmic evolution into utter chaos after all. In fact, a research team led by Dale Kospsky has come to the conclusion that the light emitted by the objects is not actually of stellar origin at all, but most likely comes from black holes. After taking another look at the spectra of the so-called little red dots, the experts realized that a large proportion of them show evidence of very fast movements of up to 1,000 kilometers per second. And the bottom line is that such a pattern is not typical for very early massive star clusters, but rather for the accretion disks of black holes. This refers to the disks of gas and dust that surround the mass monster inside and constantly supply it with new matter. Applied to the impossible red dots, this means nothing more than that around 70% of them are ultimately not inexplicable galaxies after all, but growing black holes, also known as active galactic nuclei. And by implication, where the majority of the light does not come from stars but from accreting black holes, there is no need for an impossibly high density of matter to explain their existence. In conclusion, Webb has not presented us with an unsolvable mystery but rather with an insightful indication that black holes grew much faster in the young universe than previously assumed and played a fundamental role in galaxy evolution almost from the start. But does this mean that the mystery of the little red dots has finally been solved? Well, not quite yet, because apparently the objects disappeared from the cosmic scene again after about 1.5 billion years. And so far we don't know what the reasons for this sudden disappearance are. No less confusing is the fact that despite their remarkable brightness, black holes emit very little X-ray radiation, which is unusual for active galactic nuclei to say the least. The overwhelming light echo of stellar death supernovae are undoubtedly among the most powerful spectacles in the universe. And on December 23rd, Webb even captured the remains of a stellar explosion that occurred in 1680 in the constellation Cassiopeia, 11,000 light-years away. The relics left behind by this violent stellar death are known to researchers as Cassiopeia, or CSA for short, and they reveal things that previously seemed completely invisible. After all, the light from the supernova continues to illuminate the surrounding gas and dust layers to this day. But the most remarkable feature of the Webb images is the so-called light echo. This phenomenon occurs when the light from a supernova explosion encounters and reflects off the surrounding interstellar medium. The intensity of this radiation can in turn heat up the gas and dust in the surrounding area, causing them to glow themselves. And now Webb has captured these echoes in a stunning level of detail that has left even the most experienced astronomers open-mouthed. Jacob Jensen, the head of the scientific program, says, "We were quite shocked when we saw this level of detail." And his colleague Josh Peak added, "We see layers like an onion. We think that every dense, dusty region we see, and most of those we don't see, look like this on the inside. We've just never been able to see inside them." And we realize why the experts are so enthusiastic when we consider that Webb itself has revealed the finest details reminiscent of the branches and swirls of a wood grain. In this way, the researchers were able to map the true 3D structure of the interstellar medium for the first time ever. Among the most striking details are densely packed, leaflet-like structures that occur on remarkably small scales of about 400 astronomical units. And just to recap, 1 astronomical unit corresponds to the average distance between the Earth and the Sun, which is around 150 million kilometers. And what for us still represents an unimaginably large distance is unexpectedly puny in the vastness of space. Because as Peake said, we did not know that the interstellar medium has structures on such a small scale, let alone that it is fold-like. These structures could be influenced by interstellar magnetic fields. The aforementioned branches in the wood grain could in turn be magnetic islands embedded in the more streamlined magnetic fields that permeate the interstellar medium. In view of these breathtaking insights, the scientists are looking to the astronomical future full of energy and state that the way they study the interstellar medium will change completely in the future. An extraordinary dwarf located about 5.3 million years away from us, an amazing dwarf galaxy called Lyapunov, is out there slumbering, and it has a big surprise in store for experts. The structure basically includes a few 100,000 stars but has a particularly large gas component compared to its stellar population. In addition, scientists found a huge supermassive black hole in its center, which, given the relatively small size of the galaxy, was an enormous surprise. This finding suggests that even such tiny galaxies may harbor gigantic black holes, and could fundamentally change our view of galaxy formation. The Lyapunov dwarf could therefore be a missing link in our understanding of how the earliest galaxies and their central black holes co-evolved.